Okay. Good afternoon, class. This is Mrs. Olukunle. We want to talk about periodic table. As you can see, this is SS1 chemistry class. Of course, we've treated it before, but we just want to have this class so that we can cross our T's and dot our I's. In our previous class, we said that the periodic table is just a table that depicts the arrangement of elements into groups and periods. Now, when we talk about groups, remember we said for groups, elements that belong to the same group have the same valence electrons. And when we talk about valence electrons, we are talking about the outermost electrons. Okay? And we said for periods, elements belonging to the same periods have the same number of electrons shared. Right now, I'm going to draw a sample of the periodic table. I'm going to use that of the first 20 elements, showing their groups and periods. Here we have, I'll run it from group 1 to group 8, and then we're going to take from period 1 to period 4. Okay? Remember the memory tip you know for the first 20 elements. You can use this. It has light gray, but can not offer full natural science. Many art students prep science courses as core career. I'm going to explain what this means. This is we are arranging the elements in order of the atomic numbers. This is 1 for atomic number 1. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is 18, 19, and 20. The one with atomic number 1, this stands for hydrogen. This is the symbol. Atomic number 2 stands for helium. Helium is a noble gas, so we'll put it in group 8. The next one is lithium. Atomic number 3. Next is beryllium. Atomic number 4. Next is boron. Atomic number 5. Next is carbon, nitrogen, oxygen. I made a mistake. 3, 4, 5, 6, 7. It has light beam but cannot offer fluorine, natural. This is neon. Science, that's for sodium. Atomic number 11. Many art students, which is magnesium. Proof. As for career, he has light brain but cannot offer full natural science. Many art students prove science courses as poor career. This is my own memory tip. Of course, we can use any suitable one for you, but this is one of it. All right. Now, if you're going to write out the electronic configuration of these elements, that margin, this margin. If you're going to write out the electronic configuration of this is 1, this is 2, this is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. This is 2, 8, 1, 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 287, 288, 2881, and 2882. You will notice something. All these elements in group 1, they all have one outermost electron. You can say this is outermost electron, same thing as valence electron. For elements in group 2, they all have 2 electrons in their valence shell. Same thing for elements in group 3, they have 3. For elements in group 4, they have 4. In group 5, they have 5. In group 6, they have 6 valence electrons. In group 7, they have 7. And in group 8, they all have 8. Only helium has 2 because it has only 2 electrons. Is that right? And it's a noble gas. That's why it's in group 8. Okay, that's that about the periodic table. Now, there are some properties of elements that vary down the group and across the period. I'm going to wrap up this. You can put it down on your own. My magic. All right, we're going to be talking about some properties. Properties. The properties we're going to be talking about, we'll start with the physical properties. Physical properties like boiling points and melting points. Melting points and boiling points. We're also going to be talking about the ionization energy. As well, we'll be talking about electronegativity. Now, we're starting with the physical properties, melting and boiling points. How does this vary? These properties, the variation of these properties, of each of these properties is called, this variation is called periodicity. Periodicity. That means the variation of properties down the group and across the period. Let me put it in a proper way so you can see it better. That's the variation of each of these properties down the group and across the period. Now, when we talk about these physical properties like melting and boiling point, we have from group 1 to group 8 elements. Now, from group 1 to group 8, sorry, 1 to 3. They are all metals. You know the properties of metals? High boiling point, high melting point. They are soluble in polar solvents and the likes. So from group 1 to group 3, they have high boiling and melting points. Permit me to abbreviate. BP stands for boiling point, while MP stands for melting point. Now for group 4, from the periodic table we just drew here, you see that an example of element in group 4 is carbon. Carbon, yes, carbon. And you've treated carbon and its compound. We said we have crystalline and non-crystalline form of carbon. An example of a crystalline form of carbon is diamond. And one of the properties is that diamond is crystalline in shape. And when it says it's crystalline, that means it's very hard. Diamond can cut the hardest elements. So that's why it's very, very hard. Is that okay? All right. For group 4, they have very high boiling and melting points because they exist in crystalline form. High melting and boiling points. That's for group 4. Now, from group 5 to group 0, I can say group 5 to group 0 or group 5 to group 8. I'm talking about the noble gases. You can as well call them the rare gases, inert gases. All right, from group 5 to group 0, they have very low, they have low melting and boiling point. The reason being that they have covalent bond in them. And remember, when we talked about chemical bonding, we said one of the types of bond we have covalent, and one of the properties that they have very low boiling point. So this exists, and it exists between non-metals. When you have two non-metals, let's say for instance in the compound like sulfur 4 oxide, sulfur is a non-metal, oxygen is a non-metal. When you have this, it depicts that the type of bond holding this together is a covalent bond. So it has very low melting and boiling point. Is that all right? Sulfur is in group 6. Both of them are in group 6. So they are both non-metals. So this is clear. All right. That takes us to number 2, ionization energy. When we talk about ionization energy, ionize, from the word ionize, that means something is being ionized. It's simply the energy required. It is the energy required to remove 1 mole of an electron from 1 mole of a gaseous atom to produce 1 mole of a gaseous ion. The energy that is required, that means for ionization energy, that means energy that is utilized to remove 1 mole of an electron from 1 mole of a gaseous atom to produce 1 mole of a gaseous ion. We can express this with an equation. Let's say we have something like this. The amount of energy required to remove 1 mole of an electron. I want to remove 1 mole of this electron. There's an invisible one here. Remember your map this. From 1 mole of a gaseous atom to produce 1 mole of a, permit me, there should be a positive gaseous atom here to give me a positive, and it is a gas. So this is what ionization energy. Now, I want you to take note of something. Ionization energy varies down the group and across the period. And how does this happen? When we talk about across the period. When I say across the period, remember the period table I just drew now? We're talking about from group 1 down to group 8. All right, that's across the period. But when I talk about down the group, I'm referring to period 1, period 2, period 3, and so on. Is that all right? So when I talk about across the period, I'm saying from group 1 to group 8. Now let's take an instance. Let me take period 2 as an example. Remember there, we have elements like lithium, beryllium, boron. I think this is all. This is all. I have this 2 1, this 2 2, 2 3, 2 4, 2 5, 2 6, 2 7, and then 2 8. This is period 2 of the periodic table. Now look at it critically. Remember we talked about atomic radius, atomic size, ionic size, and we said that for atomic size, volume, that for atomic size, when electrons are added across the period, how do I mean? This is across the period. You can see that if you look at this valence electron or this outermost electron, you see that it increases. That means electron is being added to it. From 1, it moves to 2, to 3, to 4, and like that. So when electron is being added, there's something called nuclear charge. Nuclear charge is a kind of attractive force that is present at the nucleus of every atom. Now, as more electrons are added to each of the atoms, nuclear charge increases. And when it increases, it pulls, as more electron is being added, it keeps pulling the electron to the center of the nucleus. As more electrons are being added, the nuclear charge increases. It's like saying that, let me give an instance. Let's say I have a grinding machine. Now, when it first starts, it doesn't start very fast immediately at once. The speed increases gradually, and the effectiveness also increases. Is that okay? So what I'm saying is that as the nuclear charge increases, as the number of electrons increases, nuclear charge also increases. And so as more electrons are being added, it increases the more. So as more electrons are being added, the nuclear charge also increases. So we can say that the number of electrons being added is directly proportional to the nuclear charge. That's what I'm saying. Okay? So since the nuclear charge increases and the nucleus pulls more electrons to itself, as it pulls more electrons to itself, the atom shrinks. The atom becomes smaller. I said the atom shrinks, it becomes smaller. That means the size of the atom decreases. Did you get that? I said the atom shrinks, it becomes smaller. That means as number of electrons increases, nuclear charge increases. Therefore, the nucleus pulls more electrons to itself and makes the atom to shrink or to become smaller. Why am I explaining this? How is this related to ionization energy? Now, we said it is the energy that is required to remove one more. Now, that means as more electron is being added, the nucleus pulls more electrons to itself. Now, will it be easy to remove the electron from the atom? No, because as the number of electrons increases, the nuclear charge makes the nucleus to attract or pull electrons to itself. Therefore, it will not be easy to remove. It's like saying that I have someone here. Let's say I have an SS3 boy here. I have a GS1 boy here. You know that their strength will vary. Now, both of them, let's say they have a kind of rope they want to pull to themselves. The boy in SS3 will have more strength to pull electron to pull the rope to it himself than the one in GS1. So that means that for the student in GS1 to now take the rope from the one in SS3, he has to exert more strength. In fact, it may get to a point that he has to start begging him to give him the rope. He has to beg because he knows that the one in SS3 is stronger than him. So what I'm saying is that for electron to be removed since the nuclear charge has increased, that means the power of the nucleus to attract electron to itself. That means more energy will be needed to remove electron from the atom. So this is it. The energy that will be needed here will be lesser than this. I'm saying that the energy that's needed by this will be more than this. The one that will be needed by this will be more. The energy that will be needed to remove one electron from this one will be more than this. So you can see that just the way I explained it, the ionization energy will increase. It will increase across the period. Is that okay? It increases across the period and decreases down the group. That's just a simple explanation of how ionization energy varies down the group and across the period. If you have more questions, you can see me later. So that's on this. Quickly, I want to talk about electronegativity, and after that, we'll be tidying up the class. Electronegativity is simply the power of an atom it is simply the power of an atom to attract electrons to itself. I'll still use the period 2 as an example. Lithium, barium, boron, carbon, nitrogen. This is period 2. All right. Now I have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and then 2, 8. This is period 2 elements. All right. You know, between group 1 and group 3, this is group 1, group 2, group 3. From group 1 to group 3, they are all metals. Group 4. Group 4 may have both metallic and non-metallic features or characteristics. Okay, so we can say that group 4 to group 7, they are non-metals. And you know, of course, group 8, they are unreactive. That's why we call them noble gases, inert gases. Is that okay? All right. You know, we said electronegativity, it is the power or the ability of an element or an atom to pull electron. When I say pull electron, I also mean attract electron to itself. Now, remember metals. For metals to react, what they do is they react by losing electron. They lose electron. They react by losing electrons, while non-metals react by gaining electrons. Now, if you look at the electronegativity aspect, that means for group 4 to group 7, that means they have very capacity. They have the highest capacity to attract electrons to themselves, especially these group 7 elements. Elements like fluorine, iodine, and the likes. They attract electrons to themselves very easily and very fast. That's why they are the most electronegative non-metals. So that's why you can see that electronegativity increases this way. It increases this way because this one we have the highest. All right. So when we say the trend now, look at it. Electronegativity increases across the period. It increases across the period because fluorine have the highest or reactive power. So it increases across the period and and decreases down the group, down the group. Yes. If you have questions, you can see me later. But quickly, I want to, we talked about classification of elements of the periodic table. We said from group one, these are their groups. Group one elements are called alkali metals. Group two, they are called alkali earth metals. Alkali earth metals. Group three, they are called boron family. Group four, what are they called? We said they are called carbon family. Group five, can someone tell me what they are called? We said they are called nitrogen family. Group six, what? Oxygen family. For group seven, they are called halogens, and we can also call them salt formers. Salt formers. And for the almighty group eight, they are called what? Noble gases. You can call them or inert, noble inert or rare gases. Thank you so much for your time. That brings us to the end of the class.